All right, so I think this is recording. We're solving triangles. They give us half the information that includes at least one side, and they want us to find the other half. So there's three lengths and three angles inside every triangle. That's what we want to do. So here they're giving us the measure of angle C and the lengths of A and B. So this is referred to as the side angle side case because um, we know two sides and the included angle. So this is angle C. So let's call this 11, which means this is angle A, and let's call this 17, which means this is B. Ah. So we know this length of B. We know this length of A. We're going to use the law of cosines. We use the law of sines when we know not only the angle measure, but the length of the opposite side. And I'll generally refer to that as a pair. That you know the pair of C's, or you know the pair for B's, or you know the pair for of the A's. When I have a pair, I use the law of sines. If not, I'm going to use the law of cosine. So I'm going to start out by finding the length of C. I go to my reference sheet, and it has a formula. I don't have to have this memorized. But you can see it's almost the quadratic formula, but then it has kind of an adjustment factor since it's not necessarily a right triangle. If the angle C were a right angle, the cosine of C is 0, and you get the Pythagorean theorem. So that's why it works for all triangles. See, the Pythagorean theorem is only going to be valid for a right triangle. As soon as that angle C is different than 90, we have to use this equation, not the Pythagorean theorem. All right, so since we're trying to find C, we need to take the square root of both sides. That'll get rid of this radical, or excuse me, this square. And I need to take the square root. Now, normally when I take the square root of both sides, I have to introduce a plus or minus sign. I'm not interested in negative lengths. I'm only interested in the positive square root, so I don't have to put a negative sign there. I'm ready for substitution and then jump to my calculator. I've got 11 squared. I've got 17 squared minus 2 times 11 times 17, and that included angle was 30. I know the cosine of 30, it's radical 3 over 2, but I'm still going to use a calculator to get this value. Alright, so let's jump in. Uh, we're in degrees, we're set to round to 2 decimals, so that looks pretty good. 11 squared, although I know it's 121, I'm going to key it in like that. 17 squared is probably 289 minus 2 times 11 times 17 times the cosine of this angle C, which was 30. Alright, so this gives us an approximation to 2 decimals. The length of side C is 9.28. Alright, now I have a known pair. I know angle C and I know the length of C. So I could jump to the law of sines if I wanted to. And I'm going to. But I'm going to avoid, see, I don't know yet if hidden in this triangle is an obtuse angle. I know that angle C is an acute angle, but I don't know information about angle B or angle A other than that I know angle B has to be the largest angle because it's opposite the longest side. So it's possible that angle B could be an obtuse angle. And when I use the law of sines to find this angle B, I'm going to have to use inverse sine, and the inverse sine is going to return an angle not that's obtuse, not in quadrant 2, but in quadrant 1. So I need to, if I'm going to switch to the law of sines, I need to find angle A first, just to be cautious. If I'm sticking with the law of cosines, I don't have to worry about it. But I'm going to find angle A by taking the sine of angle A. I know that this ratio of the sine of A divided by 11 is the same ratio as the sine of 30 degrees divided by this length that I just found 9.28. So this means that the inverse sine, I'll use this ratio, 11 times the sine, and the sine of 30 is 1/2. All right, so I'm expecting this to be, I know for certain that the inverse sine is only going to return angles in quadrant 1. Angles that are in quadrant 4, when you use the inverse sine, are negative angle measures, and inside a triangle I don't have negative angle measures. So I know this is going to be a quadrant 1 angle, and I also know, since it's not opposite the longest side, that would be correct. There's no way that this angle A should be an obtuse angle. All right, so let's jump to the calculator. The inverse sine of 11 times the sine of 30, which is just 1/2, close that, divided by 9.28. I don't need to close that, but I will. So I'm getting an angle of 36.35 degrees. All right. Now that I know two of the three angles, I can use my triangle angle sum theorem that says the angles inside any triangle must add up to 180. So I can find now the measure of angle B by saying, well, if the total is 180 and I take away the measure of angle C and I take away the measure of angle A, what I have left is the measure of angle B. Alright, so let's hope that I haven't made any silly type of error. The silly errors are accidentally keying in a value wrong, or changing a positive to a negative, or vice versa, making mistakes with signs. So, hey, this is an obtuse angle, so I was smart in avoiding finding the measure of angle B using the law of sines, because it would not have given me 113.65. It would have given me the supplement of this, 180 minus that angle. So, hey, we got pretty lucky. All right, so they gave us the measure of angle C. We found the measure of angle A and the measure of angle B. They gave us the lengths A and B, and we found the length C. We've done everything. We're done. I will talk to you later. I hope that helps.